How's your weekend going? So, as promised, I've actually created another notebook which has advanced functions and visualization libraries which can be used in Azure DataBricks and also in the code is actually written in Pyspark and SQL, and I have used some of the data visualization libraries as well. And I'll be showing you how to filter, manipulate, group by, select, query, and some other functions as well, aggregation functions for Spark. And the syntax is actually quite different, and it actually enables several developers to use complex grouping functions and also load specific uh, queries, big data SQL queries in Azure DataBricks. So when your data is in HDFS or Hadoop or AWS, so AWS has a SageMaker, but when your data is on the Azure Data Lake, then you can use the Azure DataBricks platform and write your SQL in the DataBricks notebook, and all your big data will be loaded and you can visualize your plots here, and they can also be exported to meetings and presentation links. So that's the fun part here. And so let's start the today's video. And for this particular analytics, I'm taking retail manufacturing sales order data. So this data set I'm taken from Microsoft. So this is how I'm loading the data engineering data sets. There are three bulk data set. They have more than 28 GB data. Okay, so this is actually big data. Unlike the wine quality data set which was shown in the last video. So this is actually big data. It has 28 GB greater than data and 277,000 records. And I'll be actually combining all the using wget. You can load the, like, this is the location where I'm loading the data, dbfs databricks file storage, and this is the link of the URL of the data set. So using wget you can actually get any particular files from any particular GitHub or anywhere servers or anything, using you can specify the address here. And %sh means shell commands. So I'm removing all the data which is there in my dbfs, and I'm making a directory in the dbfs data, and I'll be loading all my CSV files into that particular location as 2020.csv, and all this data will be combined CSV files. Excuse me. So after combining all the CSVs in the CSV format, then I'm reading it, and you can see the data has been loaded, but there are no headers here, and I have to specify the schema. So I'm defining my schema for my sales orders, and I'm actually tried to name the sales order as per like whatever I have felt like naming, because this is you can see that this data frame, like RDD silent data frame, this is the quantity, the email of the customer, and since this is a retail customer data set, then the purchase date and the quantity, the order number, like that. I have tried to name it as per whatever was given in their data set information. And everything, like, you have different kind of data types here. Like, every time you try to mention or create a RDD, then we have to give the string type or date type, or integer type or float type, like that. And we can actually specify the format of the data as well, if we want to import or export, like TSV, CSV, blob data, and then flat files, Parquet files, and JSON files, like that. So and while specifying the schema, I'm actually loading this order schema because I want to see my raw data frame using this particular data. So you can see all my raw data has been named, and if I want to print the schema, if you want to see my schema, and this is how my schema looks like. You can pause the video and you can actually read each column and the column name, so that you can easily understand the next parts of the video. And I'll be analyzing the data frame here, and I'm taking only 2 columns here because I wanted to see how many total orders are there, and like unique customers count, and the unique like total customers, how many customers are there, and from that how many unique customers are there. So there were like distinct customers were like 12,000, and like total order records was 32,000. And so here I have used the pandas normal filtering, like usually how we use in pandas. Now I have also tried to use the select approach to select a particular column. And similarly, if I want to see like any particular item value, like by item value I mean the product which was ordered by a particular customer. So, and one particular unique thing I have seen here in Spark is we do not have item in this particular data frame, but when you use dot where, then this df dot item, it references to the original data frame, and it tries to pull like how many ever row or quantity, whatever specific categorical items we have given here, it tries to pull this particular items, and it displays the customer name and email. So the approach is not like in Python we try to read from the left to right, but in Pyspark we read from the right to left. So that was really different here. And so we see that there were customers count 144 customers were there, and those were the unique customer. And for aggregation part, while grouping items, then we can also see that for like I wanted to see the value counts, like in pandas when we give a particular like a df of item and dot value counts, then I can see unique items in that particular data frame. But I wanted to see like value counts, and this is how you show the value count in Spark. If you want to see the granularity of a particular item, so you have to give two columns. You have to select the item and the quantity. Like quantity is a particular column, and if you group by item and if you see the sum, then you can see the quantity of the items which were ordered. If you don't even give group by, if you just give df dot select item and group by item dot sum, then you can see number of items which are present in the total data frame. So here I'm seeing number of items ordered, and the sales for those particular items which are present in the data set. So you read from the right to the left. And here you can see the yearly sales present. So because we are actually seeing only the orders data and the like whoever the customer orders data, so if you see here year, so you can simply say this is a data frame that is related to yearly data set sales. So we are seeing yearly sales. Like that, simply you can understand every year the count of the orders which were booked by customers have been increased. So now if I want to use SQL, this past SQL, then I have to create a temporary view for the original data frame. So I'm creating a temporary view called sales orders, and from sales orders I am actually selecting the complete data frame, and I'm displaying the Spark data frame. And Last time in last video, actually after taking spark.sql select star from the complete data frame, I have actually utilized .2 pandas, and I have displayed the I've displayed the records, as well as I have visualized the data using bar charts and line charts. But here I'm not using dot pandas because I actually want to I want to see the gross revenue, cumulative revenue, yearly revenue. So because I want to analyze this particular data frame, so I'm using another cell called as SQL. So if you keep practicing, then you can actually manipulate lots of data or use filtering, aggregation and SQL queries, grouping, ordering, like this on the cells. And it will actually be easier for you to understand and utilize the functions. So first time maybe when you're seeing, you might feel it is very complex, but as you keep practicing, then it will look very simpler. So this is I'm selecting the year. If you another thing is, if you give year space order date like this over here, you can see the syntax, it's quite different. Or if you give the year space order date, then you can see actually the year instead of casting and giving the date. You can actually give year of order date, and it is simple SQL over here, and I'm showing you the yearly gross revenue. So if you want to see this queries, then you can pause the video and actually type in another Azure DataBricks notebook. By using any new email, you get free Azure data subscriptions. So you can actually type this and save it onto a GitHub and show it to potential recruiters. So if I want to visualize the data in Spark, then I'm taking the query and I'm actually executing it. And this is how you execute a Spark SQL query. You can say this is Spark SQL, and see, again when I'm using matplotlib or Seaborn, like that, then I'm actually doing 2 pandas, and you can see the total gross revenue as a bar chart here. And similarly, again I'm clearing the plot every time I am trying to I'm trying to draw a new graph. So this is again a customized bar chart which shows the revenue per year. It is an increasing revenue. So in the explicitly, I'm also showing you clearing the plot, and in this particular, what's the difference between these two? Okay, 1 minute. Okay, here I'm telling you like how should we use one figure or two figures while doing the plotting, and also how to include multiple figures or subplots. So here I'm plotting a bar chart and a pie chart here, which shows gross revenue per year, like the yearly sales, and also sales like the number of sales which is increasing quantity in pie chart form. So similarly, like matplotlib, it is a classic analytics function which tells you like and shows you different kinds of data, but you have to write a lot of code like ax1 ax2 like this. So using matplotlib as a base library, several other popular visualization libraries have been invented and discovered, and one of them is Seaborn, another is Plotly, and you also have another libraries like Wand, where neural networks can be viewed. But now I'm using Seaborn. So in Seaborn bar chart, you can simply give the complete sales data and the column names, whichever column names you want, like the gross revenue and the order year in the x and the y axis, and you can see the chart. This can also be imported or exported. And again I'm clearing this plot, and I'm using plain Seaborn here with an axis. So by the axis I mean like the subplot. So here you can have the figurative line chart, and here we can have the pie chart like that. So it is a very nice form of visualization. And we can also do 3D charts in Seaborn, and using matplotlib and plotly, where they can be explored. So I'll try to you can actually see plotly figures in my Kaggle profile, because I have actually created a completely interactive plotly figures. I'll actually paste down the URL for that plotly notebook down. You can see how and you can see and interact with my plots and graphs with the results of that particular code in competition. It was a birds competition, I guess. Okay, I'll try to find out that notebook and paste it down. So if you want to see this particular code, then you actually have to pause the video and write the code with me, or I can also paste the code link, but I have to delete the resource. So I'll try to export this notebook to GitHub or um, some other kind of platform where I can actually share it with you, so as HTML or something. Okay, thanks for watching my video if you came this far to watch my video, and if you stayed till here. So share my videos with someone who might like to code and who likes to explore big data, and also who's interested in learning about cloud platforms, or see you soon in the next videos. And you can actually access my another notebook where I have coded the wine dataset, and that is a simple notebook where I have used Pyspark to explore which quality of wine is the best wine, and which wine is actually very popular, and the quality wise which wine is best chosen around the world. So I have taken a wine quality dataset, and I have utilized Pyspark, Spark, SQL, and some visualization libraries to find out the best wine. So if you are interested in that, you can click on the link of the video, which is pasted as the recommender. Okay, see you soon. Goodbye.